We know already that there are three parts to a SIP request: the start line, the headers, and the message body or payload. In this module, we'll look more closely at the message body, particularly how it's used for conveying media options. By the time you've mastered this module, you'll understand what can be conveyed in the payload and how the exchange of media options enable both parties to stream media packets. You'll also be familiar with two essential SDP headers, and you'll understand how codecs are referenced. Now, SIP doesn't really care what goes in the payload. It's just a space in which one user agent can send non-SIP content to another. It can be plain text, perhaps an instant message or a link to another resource. It could be some application data, perhaps some XML data that both parties use to keep in sync. Usually though, particularly with invite requests, the payload contains a session description, as defined by the Session Description Protocol, SDP, information through which user agents set up the exchange of media packets, the media stream. Now, this media stream data is known as media options. Let's spend a few moments now on the subject of media options. Media options provide the caller's media details to the callee. We know already that media, maybe audio and video, is encoded by a codec, the resulting binary representation put in a media packet and sent downstream. But sent where downstream? To which IP address and which port? And which codec do the user agents use to encode and decode the media? Well, that's where media options come in. I think of media options like a calling card I supply to the other party, telling him what codecs I have. In this case, a choice of 3 audio and 3 video codecs, and telling him the IP address and ports on which I'm expecting to receive his media packets. When he receives my invite and extracts my media options from the message body, he knows what codecs I have and how to send his media packets over to me. Remember, this media description is nothing to do with SIP. SIP just carries the description in its payload. Media options are defined through a different protocol, the Session Description Protocol. So, how should we read the SDP here? Well, my eye goes straight to the M equals SDP header, M standing for media. There'll typically be an M equals header for each media type that we're willing to use, one for audio and perhaps another for video. Next on the M equals line is the port through which our user agent is expecting the downstream agent to send his media packets back to us. Then there's the chosen transport protocol by which the media packets will be delivered, in this case RTP, the real-time protocol, or AVP, the audio-video protocol. Finally, each M equals header ends with references to the codecs the user agent is willing to use to encode and decode the audio. It's vital that both upstream and downstream agents use the same codecs. Just for your information, 8 represents the common G711 A-Law codec, 0 the universal G711 U-Law codec, and 34 the H.263 video codec. Now, these and other common codec references are found in RFC 3551 at ietf.org. Note also that non-standard codecs can be dynamically referenced through RTP maps. The 96 and 97 in the M equals audio line don't refer to any specific listed codec. In fact, we see that 96 to 127 are listed as being dynamic, for referencing codecs that don't have their own static reference. If, for example, we want to use a non-standard codec that employs a 16-bit linear encoded stereo audio sampled at 16 kHz, then we'd choose a number from the dynamic range and add it to the M equals audio line, mapping it to an A equals line that specifically defines the bit rate, the sampling rate, and the number of channels. Now, don't worry, you don't have to remember all of this, just know where to look it up when you need it. The other SDP header that you'd be well to know about is the C equals header, C standing for connection. It tells the downstream agent which IP address to send his media packets back to us. Take a look at this C equals address. Do you notice anything? Well, it's not the address of the user agent, but the address of another entity. Now, what do you think will happen when these media options are passed downstream? Well, the downstream media packets will be routed to the address in the C equals line, to the 192.168.194.93 entity. Interesting. Normally, however, user agents include their own address in the C equals line. Now, I read these media options as saying, send your media packets to IP address 192.168.0.22, where I'll be listening on port 29286 for your incoming RTP audio packets. Oh, and I'm okay with either of these audio codecs, 8 and 0. Now, one more thing real quick before we finish. It might be useful for the downstream client to know from where the SDP offer originated. That's the purpose of the O equals header. The IP address in the O equals header gives the address of the agent making the SDP offer. O equals stands for originator. Okay, let's summarize. We've talked about the message body being a place within the SIP message after the SIP headers or the carriage return line feed in which non-SIP content can be conveyed. Examples of common payload are text, hyperlinks and XML, and of course SDP media options. Media options are descriptions of codecs and addresses and ports through which agents can establish media streaming. Media options include the M equals SDP header that describes available media types such as audio and video. It also includes the port through which media packets will be received, and it references the codecs that can be used to encode and decode the media. The media options also includes a C equals SDP header that defines the IP address to which the downstream agent should send his media packets. Media packets can be sent to a third party, such as a conference bridge, by including the third party's address in the C equals header. A media options description also includes an O equals header that shows the originator of the SDP offer. Finally, we looked at some common codecs, 8 for G711 A-Law audio, 0 for G711 U-Law audio, and 34 for H.263 video.